Hi guys, welcome to Space Gate Engineering Academy. Now we are going to discuss about relationship between alpha, beta, gamma in electronic devices and circuits. Guys, here we must know about what is alpha, beta, gamma before going to make the relationship among themselves, isn't it? Yes. Now guys, what is alpha, beta, gamma? Remember guys, we have three configurations in BJTs. They are common base, common emitter, common collector. Yes, there are three configurations. So the same common base configuration looks in this way guys, where the emitter is input, base is common to input and output, collector is output. This is output, this is input. Similarly, for common emitter, the circuit looks in this way, where this is output, where collector is output, base is input and emitter is common for both input and output. This is what common emitter configuration. Similarly, common collector configuration as well, where we measure the output across emitter, collector is common and output measures across the emitter terminal and base is the input. So guys, in a simple way, the configuration wise if you consider common base, common emitter, common collector, the input terminal is definitely emitter and the output terminal is collector. So common terminal is base. Similarly guys, in common emitter configuration, base is input terminal, collector is output terminal, emitter is common terminal. And coming to the common collector configuration, the output terminal is, the input terminal is base, emitter is output terminal, collector is common terminal. This one guys, this is a simple overview regarding the configuration. And guys, remember, every time when you see the configuration, don't look for the common terminal. Common terminal is base, it is not like that. And you need to identify the inputs and outputs, where you have applied, where you have considering the output. According to that, you need to specify the configuration, not with the particular ground or whatever. Remember, the input and output terminals only you must say regarding the configuration, not the common terminal, always. Remember. Now, coming to the point guys, here what is meant by gain? Even in any business language also, gain means how much we have spent, how much we are getting. That means output by input, simply. So gain means output by input. Gain is represented by the letter A, that is output by input. Suppose if it is a current gain, it is denoted by the letter AI. The formula is I out by I in. Similarly, what is power gain? Output power by input power. Voltage gain means output voltage by input voltage. That is what current gain, voltage gain, power gain. Remember. Now, the point is alpha, beta, gamma. Now guys, here you can see in a common base configuration, the current gain is denoted by the letter alpha. That's it. Problem is solved. Simple guys. Alpha, it is simply the current gain of common base configuration only. That's it. Now guys, the basic formula is I out by I in for the current gain, isn't it? So in this, what is the output current? IC. What is the input current? IE. So guys, here the AI which is alpha is IC by IE only. So the basic definition of alpha is IC by IE. This one, guys. Similarly, what is common emitter configuration current gain? It is denoted by the letter beta. Now you see the configuration and tell me what is the output current? IC. What is the input current? IB. So here beta is, according to this formula, I output by IN, whereas the current gain of common emitter configuration beta, that is IC by IB. This one, guys. Similarly, now common collector configuration. What is the output current? IE. What is the input current? IB. So what is the current gain formula? That is, in common collector configuration, the current gain is denoted by the letter gamma. So guys, here the gamma formula is IE by IB. This one, guys, gamma is equals to IE by IB. Got it? Now guys, let's have a simple analysis where there is a PNP transistor. Let's assume emitter, base, collector. From emitter to base there will be a emitter junction. This is the emitter junction. Always the emitter junction must be forward bias. Hence P to P, N to N. Whereas for proper operation, we know, guys, for a proper operation of a transistor, if you want to use the transistor as an amplifier, emitter base junction must be forward bias, collector base junction must be reverse bias. So that now collector to base junction, guys, like this. So that P type semiconductor to the negative terminal, N type semiconductor to the positive terminal. Here I can say only the emitter and collector terminals, the biasing supply is very important. Now guys, now the transistor is operating in the active region because emitter base junction is forward bias, collector base junction is reverse bias. Let's assume from emitter region, for example, 100 holes enters into the base region. Let's assume in N-type semiconductor 10 electrons are there. So that 10 electrons and 10 holes gets cancelled, I mean recombine, and the remaining 90 will go to the collector region. So guys, let's assume the emitter current is 100, base current is 10 because 10 electrons and holes got recombined, right? So the recombination current, the base current is 10 only. Just let's assume. Now collector current is 90. Now guys, you substitute in this formula, alpha is equals to IC by IE, that is 90 by 100, then definitely alpha value will be less than 1 only. Remember guys, alpha is always less than 1. Got it? Similarly, you take beta, where beta is IC by IB, 90 by 10, it is 9. So it is greater than 1 only. Beta is always greater than 1. Similarly, gamma, gamma also 100 by 10, that is 10 only, more than beta. Hence guys, I can say gamma is also greater than 1. From these values, we can conclude one point, that is alpha less than beta less than gamma. So among the three, the highest value is obtained by gamma only. Guys, hope you know the typical value of alpha is 0.90 to 0.995. Whereas beta, it is some 50 to 200 or max 500, not more than this. Even gamma also among there only. And even guys, gamma can also be written as IE by IB, right? This IE can be written as IC by IC plus IE by IB. That is IC by IB beta, IB, right? IB by IB gets cancelled, it is 1 plus beta. So guys, gamma can also be written as 1 plus beta. Yes, it's gamma. So more than beta. That's why I have written alpha less than beta less than gamma. Even the same, even in a different configuration, you can write AI CB, AI CC, CE and AI CC. That's what only, right? You can say like alpha less than beta less than gamma, or AI CB less than AI CE less than AI CC. All are same only. See, till now we didn't enter into alpha beta gamma relationship, but still we learned some of the points. Very important. Alpha is less than unity, beta is always greater than unity, gamma is goes to 1 plus beta, alpha less than beta less than gamma. What is alpha, beta, gamma in their respective configurations? How many configurations are there? All these are very, very important questions, guys. And when you say the SpaceGate Academy videos, all are HD videos. You take pinpoint search, then also you don't get any error. Honestly, proudly we are saying, guys, see, behind that there is so much of hard work, there is so much of efforts by so many people. So you just subscribe our Space Engineering Academy and you join our course, so that you will get a clear content. If you learn, if you watch our videos, if you write whatever we have conducted the online, offline exams and practice our whatever the materials, that's are like they are enough. No need to refer any other textbooks or YouTube videos or textbook like previous questions and all. No need at all. We will give you a clear picture. Video lectures and then GATE previous questions, ESC previous questions, ISRO previous questions, ESC, ECE, ESC, EEE, GATE, ECE, GATE, EEE, instrumentation, all the questions in a single package. You will get all the videos. Otherwise, you download our SpaceGate Academy app and there you can see. Of course, you can't like watch those videos, but you can see how many videos are present. There is a clear cut presentation, guys. Got it? Now let us continue. So guys, now we have completed the alpha, beta, gamma introduction, not entire concept. Just we have finished the introduction. Now guys, the output collector current equation is IC is equals to alpha IE plus ICO. This is the collector current equation, guys. We know very well the emitter current IE is equals to IB plus IC. Now if you substitute in that expression, IC is equals to alpha into IB plus IC plus ICO. Now if you move the terms, guys, IC minus alpha IC is equals to alpha IB plus ICO. Now guys, if you take IC as common, IC into 1 minus alpha is equals to alpha IB plus ICO, and when you simplify, guys, IC is equals to alpha by 1 minus alpha IB plus 1 by 1 minus alpha ICO. This one, guys. Similarly, here let's assume alpha by 1 minus alpha as beta. Let's assume, so that here in place of this you can write beta, but what about 1 by 1 minus alpha? We want to know. So if you want to calculate what is 1 by 1 minus alpha, you must know about alpha. For that, guys, first what we do is we'll cross multiply beta minus alpha beta Yeah, is equals to alpha. Now guys, beta is equals to alpha plus alpha beta. Take common alpha into 1 plus beta. So guys, what is alpha? Beta by 1 plus beta. Now if you substitute this alpha in this term 1 by 1 minus alpha, 1 by 1 minus alpha, that is 1 by 1 minus alpha is beta by 1 plus beta. So guys, denominator to denominator becomes numerator 1 plus beta by, again you take LCM 1 plus beta minus beta, gets cancelled, you get 1 plus beta only. That means guys, if you assume alpha by 1 minus alpha as beta, then 1 by 1 minus alpha becomes 1 plus beta. Hence guys, here the collector current equation IC is equals to alpha. Exactly speaking, here IC is equals to beta IB plus 1 plus beta times IC naught. This one guys, this is what IC is equals to beta IB plus 1 plus beta times IC naught. Remember. Now see, this is the collector current equation. Yes, wherever the beta is there, hence we can tell this is the output collector current equation for a common emitter configuration. Remember guys, got it? And now the point is, what is the relation between the alpha, beta, gamma? Alpha is equals to beta by 1 plus beta. Beta is equals to alpha by 1 minus alpha. Gamma is equals to 1 plus beta. Just now in the derivation we have derived that gamma is 1 plus beta, that is equals to 1 by 1 minus alpha. This is the relationship between alpha, beta, gamma, that is gamma is equals to 1 plus beta is equals to 1 by 1 minus alpha. This one guys, this is what the relation between the alpha, beta, gamma. Got it? Now guys, let's have a numerical based on relation between alpha, beta, gamma. Whatever we have studied the alpha, beta, gamma relationship guys, whether it is going to working out or not, tell me. Let's see, there is a proof. Guys, now what is the question? The DC current gain beta of a BJT is 50. Assuming that the emitter injection efficiency is 0.995, the base transportation factor is, guys, here they are announcing a new words called emitter injection efficiency, base transportation factor. Guys, till now we have discussed about alpha, beta, gamma. But what about this? Of course, they have given the beta value 50. But what about emitter injection efficiency? What about base transportation factor? Everything. This and all you must know. Remember. Now let's have, guys, there is a PNP transistor, emitter, base, collector. Guys, here remember emitter injection efficiency denoted by the letter gamma, that is the number of carriers injecting from emitter to the base to the total carriers crossing the emitter junction. Guys, whatever the carriers are injecting into the base from the emitter, that's what the name, emitter injection efficiency, that they are injecting into the base, that is IPE. Let's assume IPE. IPE is the whole diffusion current, because we are assuming it is a PNP transistor. from p-type semiconductor, whatever the holes which are majority carriers injecting into the base, that's what emitter injection efficiency divided by the total carriers crossing the emitter junction. Guys, here the total carriers are IPE only. In addition to the IPE, there are some electrons present in the p-type n-type semiconductor as a majority carriers. They move from emitter, the base to the emitter. That means they are crossing the junction only, right? So the emitter injection efficiency is IPE by INE plus IPE. This is the emitter injection efficiency. Guys, remember the INE, whatever that electron diffusion current is very less, because the base is lightly doped semiconductor. Here we can say, like as a whole, even though the INE's value is very less, as it is total, and that is only the majority carrier current which is entering into the base from the emitter, with this formula we can say gamma is IPE by the total emitter current IE. Remember guys, now here we need to know about base transportation factor beta star. Here transportation, how much is incoming into the base, how much is leaving from the base, that is what transportation. So how much is coming and how much is leaving. So here the base transportation factor beta star is equals to, guys remember, whatever the carriers are coming from the emitter, some of them are going to the base region itself as a recombination current, and the remaining are going towards the collector. Got it? Now guys, here whatever the carriers are going towards the collector, let's assume that is alpha IE, where alpha is that what we call the current gain of a common base configuration. That's now here whatever the beta star, the output current is going towards the collector is alpha IE by, here guys, what is the current incoming into the emitter, that is IPE only. Okay. Now guys, now let us multiply these two factors, gamma into beta star. What is gamma? IPE by IE. Means this IPE plus INE, we assume it as IE, the total emitter current. Now gamma into beta star, IPE by IE into alpha IE by IPE. So guys, here then it is definitely like let me write IPE by IE into alpha IE by IPE. Guys, IPE gets cancelled, IE gets cancelled, we got alpha. So guys, here remember alpha is equals to gamma into beta star. Whatever you have studied, alpha, beta, gamma relationship may be useful for state level PSUs, but there is a lot more formulas beyond the alpha, beta, gamma. Now the point guys, here we explored one more numerical formula, that is alpha is equals to gamma into beta star, where alpha is the current gain of common base configuration, gamma is emitter injection efficiency, beta star is base transportation factor. Remember, even see here whatever the current is out from the recombination is alpha IE, and this recombination current we assume it as 1 minus alpha into IE. So that guys, if you take 1 minus alpha into IE plus alpha IE minus alpha IE plus alpha IE gets cancelled, you will get IE only. So even equation wise also it is same only. So we are not at all disturbing the original equation. So guys, in addition with the alpha, beta, gamma formulas, we have one more formula called alpha is equals to gamma into beta star. Now guys, very important thing is they asked us beta star. Okay. Now guys, here alpha is there. Is he given alpha value in the question? No. They have given beta value. Let me write here. Now guys, alpha is equals to gamma into beta star, where this gamma is not a common collector configuration current gain. It is a emitter injection efficiency. Okay. So here this alpha can be written in terms of beta, beta by 1 plus beta, and this gamma into beta star. Now guys, whatever the base transportation factor beta star is equals to beta by 1 plus beta into gamma. Now guys, the beta is 50 by 5 plus like 50 plus 1, 51 into gamma 0.995. When you simplify guys, you get 0.985. So what is the correct answer? Option 2, option B, 0.985. Guys, in front of you I can take one very simple formula. Alpha is equals to some value, what is beta? Beta is some value, what is alpha? I can do like this. But in the exams, beyond the level, you are going to get the questions based on these formulas as well. So in addition to the formulas, whatever alpha is equals to beta by 1 plus beta, beta is equals to alpha by 1 minus alpha, gamma is equals to 1 plus beta, alpha is equals to IC by IE, beta is equals to IC by IB, gamma is equals to IE by IB. In addition to all these formulas, you must remember one more formula, that is none other than alpha is equals to gamma into beta star, where gamma is emitter injection efficiency, alpha is the current gain of common base configuration, and beta star is base transportation factor. For more interesting updates guys, please subscribe Space Gate Engineering Academy. This is Shivram signing off. Jai Hind.